welcome everyone. I am going to turn it over to today's host for a few remarks and introduction of today's speaker. Our host today is Cami Baggett, who is a regional manager here with NC State's IES. Cami.
Good morning, everyone, and welcome to our Optimizing Operations, Benefits, and Types of Work Measurement webinar. We're very proud to present this. Our presenter is Holly Byrne. She is our product lead of industrial engineering and student projects, and she is an IE from NC State University. I'm also an IE from NC State University, and we've both been working together for many years. She's been with IES for 18, and I've been with IES for 19 years, so we've worked on many of these types of projects together. Next slide, please. For those of you who don't know who IES is, Industry Extension Services, we are the outreach arm of the College of Engineering. We've been around since 1955. It's our mission to reach outside of the College of Engineering and the university to work with industry and businesses. So we provide all types of services and resources to companies. And I like to say that we're one of the best kept secrets of North Carolina because people are still learning about us every day. We are a not-for-profit, and we also serve small to medium-sized manufacturers, educational and research institutes, healthcare and pharmaceutical companies, defense contractors, aerospace and energy sectors, and many, many, many other types of organizations. We have all types of services from ISO to safety to energy to instructional design services to lean, continuous improvement to industrial engineering, student projects, you name it, we can probably help. We always say that we don't know what we can do until you ask for it. So we've got many, many, many partners and resources that we can reach out to as well if we don't provide the services. Next slide, please. And for those of you who aren't familiar with IES, there is a regional manager that lives and resides and works in your territory. So this is a map of our colleagues and different regional managers across North Carolina. You've got their phone number and their emails, so you can reach out to the person who is covering your region, and they can give you more information about any of our services and how we can help you all. Thank you so much, and I'd like to turn this over to Holly Byrne, who will begin our presentation today.
Thank you, Cami and Susan. Welcome, everyone. As Cami mentioned, my name is Holly Byrne. I am a product lead for industrial engineering and student projects. I've done work measurements in my early career as part of incentive programs for the operators. So I'm very familiar with techniques by application. Back then, they also taught us work measurement. So let's dive into what is work measurement and foundation of it. The foundation principles of work measurement are primary focus. Our primary aim here is to establish objective baseline standards to eliminate shop floor waste and optimize workforce and gain tight control over manufacturing costs. Management icon Peter Docker is famous for stating you cannot manage what you do not measure. In industrial engineering, work measurement is formally defined as the systematic process of determining the exact time and effort required for qualified, properly trained worker to complete a specific task under standard operating conditions. I draw to your attention to two words. Number one, qualified, and number two, standard operating procedure. Because if you don't have those two factors, your measurement may be erroneous. So that's a requirement. We are not measuring panic pace or untrained workers. We are focusing on stable, standardized execution. Why work measurement? Why do companies invest in time in work measurement? It comes down to three main pillars. Number one, assess the capacity. You heard of demand versus capacity. Eliminates guesswork on throughput, allowing plant management to understand true equipment bottlenecks and facility limits. So if you know how long it takes for any kind of product to travel through the shop at each station, you automatically know the bottlenecks. This approach will quantify it and help you eliminate it. Number two, standardize expectations. Establish clear, objective, and repeatable target times across every shift department across manufacturing cell. And number three, drive accountability. Connects daily shop floor reality directly with organizational and business targets, customer shipping commitments, and continuous improvement goals. Where do we use time standards? Time standards aren't just for industrial engineers. This data fits into almost every department across the enterprise. Operation and costing. It is used to calculate labor cost per SKU, set realistic customer delivery lead times, validate capital machinery, return on investment before purchase, and fuel digital process simulation. For those of you that are not familiar with process simulation, it's a computer program that mimics your process. You create a model, or sometimes you may hear a digital twin of your process, and all the variables are worked into the model. So once you change certain variables, you can see the impact on the bottom line without physically changing everything. Everything's on the computer. Another thing is workforce and strategy drives headcount planning. A lot of times, we go to a lot of companies and they are underutilized, or I should say overly utilized operators. So once you know your work content, how long it takes to do a job, you can plan it accordingly and have a fair performance-based wage incentive plan as well. Benchmark plant productivity against industry peers and ensure labor compliance. I have you know that a lot of times labor unions, I know this state is not a union state, they do come to our classes for work measurement and time approach, which we'll talk later, just to be sure that their work is measured correctly. So the historical root of scientific management. Work measurement has a rich history dating back to late 19th century, excuse me, with Frederick Winslow Taylor, who pioneered scientific management using stopwatches to analyze worker motions. Then we had Frank and Lillian Gilbert expanded this by investing motion study analytics and micromotion breakdowns, coining the term Thurblig, which is Gilbert backwards, to describe fundamentals of human motions. The fun fact, the Gilbert study of surgical motion efficiency, that is your performance in, performance in the operating floor or surgery was based on motion study. Also, procedures in healthcare, a framework still used in modern hospital today. Operation, application, and costing. We focus on how accurate time data directly impacts plant financial accounting, product margin prediction, and strategic workforce scheduling. So where do we use these standard times? Another place that we use standard labor costing. My very first job out of NC State as an industrial engineer was not only to time study the operators, but also calculate the cost of the product. It's the cost of the product, as you know, other than materials and overhead, is labor costs. So this makes you understand it better and pinpoint the areas of improvement. Also, overhead allocation ensures plant burden and overhead are allocated based on realistic machine running times rather than arbitrary estimates. Also, delivery and capital planning gives sales team firm lead times that they can promise customers and give finance teams validated payback metrics before buying multi-million dollar equipment. So, as you can see, it impacts every aspect of the operation. Another thing that is applied for is strategy. Headcount and incentive allows operation managers to model required staffing levels based on seasonal demand fluctuations and design objectives. Also, for incentive programs, allows for bonus and incentive programs. Another application is governance and lean execution. Those of you that heard of Lean Six Sigma, you cannot conduct meaningful Kaizen events. Kaizen events is one of the activities in Lean where you analyze the process in order to improve it. Obviously, you have common currency if you have time as your base metric. Also, in Lean Six Sigma, projects, if you don't have the common currency such as time, which is, as you know, across the value stream map, timing is the common currency. So if you don't have the accurate times, obviously the meaningful results are not going to be obtained. So accurate standards provide the true baseline required for continuous improvement. As you can see, time standards are fit into all kinds of um, company operations, from accounting all the way to shop floor. What impact of missing time standards? What happens when a company lacks accurate standard times? Research shows a potential of 40% capacity loss. That's not pocket change. When facilities rely on unverified estimates or inaccurate historical averages, major business vulnerabilities include miscalculated labor overhead that destroys margins. Unbalanced workloads, as I mentioned earlier, created massive shop floor bottlenecks, unpredictable delivery times, as well as underutilized capital machinery. I mean, again, we go to a lot of companies and we see either people sitting idle or machines sitting idle. Of course, neither one is desirable. Once you know how long it takes to do a job, you can plan accordingly. Even in simulation that I talked about earlier, times are very important, machine run times, as well as production time and operator time. This is a real case study. It's a quote from an industrial engineer at WISC. For those of you that don't know, WISC is Institute of Industrial and System Engineers as an organization based out of Atlanta. And they have, organizations. I happen to be a chapter president in Raleigh RTP. So the blog says, my employer implemented a lean initiative over 4 years ago. Yet we still rely on very rudimentary time studies. The result, waste has not been reduced. The takeaway is that lean tools like 5S, value stream mapping, and Kaizen will fail to produce sustained return on investment if they are built on of guesswork and padded historical standards. Baseline measurements must precede process redesigns. So now that we know why we need work standards, how do we perform this methodology? This is a detailed breakdown of what are the methodologies of work measurement. So there are three approaches, the main families. Number one is estimation, which is, a SWAG, single wild guess, a scientific wild guess, historical ERP and accounting data. So historical data is fast, cheap, and highly subjective. Then we have direct observation. which is what you heard of time study, time and motion study, stopwatches, also work sampling, which we're going to talk about a little bit as we move forward. The advantage of this method is going to Gemba, where the work happens, which is one of the requirements of lean, going to the floor, putting boots on the floor, and see what's going on. Then the third method is predetermined motion time systems, or PMTS. Since synthetic modeling systems like MODAPS, MOST, and MTM that construct standard times from micro body movements. For this method, there's a database for any kind of movement, whether it's hand movement, finger movement, and then there are standard times associated with each movement. We get a little bit deeper into each one of these. So as I mentioned, estimation technique. One is SWAG, scientific wild guess. So supervisor or long tenured operators are familiar with the process. The advantage is that it's fast and quick shop floor bidding, but heavily biased by personal opinion and built-in safety padding. Also, historical production records, how we have performed in the past for this kind of job. You can guess what's the disadvantage of that is that a lot of padding, downtime, worker fatigue, or inefficiency breakdowns are going to be worked into those times. So obviously, it's going to be inflated for historical data. Then, as I mentioned, as far as the estimation, there are advantages and disadvantages to any kind of method. The advantage, of course, implementation costs, immediate results for customer bidding, and minimal disruption of production. Disadvantage, as I mentioned earlier, it is highly objective, wildly variable between estimators, and then inflates cycle times with hidden breaks and provides no visibility of motion waste or line balancing. So then we have direct Gamba observation, which is method 2, brings the analyst or the engineer directly to Gemba. Gemba, we said, is where the work happens. The actual place where value is created. Using stopwatches, handheld tablets, or video software, the analyst or engineer records cycle time, operator motion patterns, and process delays. This captures actual operating reality rather than idealized engineering procedures, because there is a lot of difference between concept to application, as you know, and engages frontline operators in identifying non-value added activities on the spot. So stopwatch versus work sampling, there are where an analyst times a qualified operator across consecutive cycles. As we mentioned, it has to be qualified. The operator, what we call in industrial engineering, normal operator. As a qualified operator, that means average speed. We don't want anybody too fast. We don't want anybody too slow, because it will distort our results, right? And then this is good for highly repetitive manufacturing tasks. What about the long processes? Places like airplane manufacturing. We have right now we're doing coach manufacturing. Those are long processes. They're not highly repetitive. So for that kind of operation, work sampling is recommended, where discrete observation involving a large volume of instantaneous randomized observations over time. What does that mean? It means that you go at randomized time, 10 o'clock in the morning, and see what's happening to the machine and the operator. You record it. You go again at another random time. You go at 2 p.m. You record what's happening. Based on those percentages, you determine work content. What percentage of the time was the operator idle or the machine idle? We've done it in the past for tire manufacturing in North Carolina, and it was proved to be meaningful and successful. So ultimately, you measure machine idle time and operator time based on percentages. So what is the advantage of direct observation? Again, it's Gamba data. You're right there on the floor. It provides high statistical confidence intervals and builds trust through face-to-face operator engagement. As you heard from Cami, we do a lot of most of our projects, all of my projects are student projects. So projects, they go on the floor, they do talk to the operator, they do talk about the purpose of the study. And so there's a one-on-one engagement, and there's always teamwork when it comes to operation improvement. Obviously, we provide support as engineering team, and operators, they know their job best and they provide insight. The disadvantage is subject to workers temporarily changing their pace when being watched, requires subjective performance rating. Um, Performance rating, as I mentioned, is something that's used in time studies. As I mentioned, normal or qualified operative, we rate them at 100%. If they're slower than that, we go below 100%. If they're faster than that, we go above that. You can also modify as you see fit for your environment. We've done it where we had average, slow, and fast, just three numbers instead of percentages. But that is a subjective assessment of how fast how the operator is working. And also the whole process, it's very labor intensive as far as collecting data, analyzing data, making sure everything's correct. So this is a trade-off. Method three, we said, is predetermined time systems, or PMTS, synthesizes task duration before production setup using standardized motion building blocks. We have MODAPS, which uses 1 mod units, which is equivalent of 0.129 seconds. For fast, highly intuitive motion coding based on body part movements, finger, hands, and arms. Then we have MOST, focuses on sequence models of object movement. So general move, controlled move, tool use. Then we have MTM, which is the foundational micromotion system and analyzing reaches, grasps, moves, and releases measured value in TMUs, which is time measurement unit, where 100,000 TMU equals 1 hour. This methodology can be used ahead of production as far as planning. So it's 100% objective. That is one advantage. So the eliminates the stopwatch and pace rating bias, which is associated with direct observation. Pre-production capable, as I mentioned, sets accurate labor standards while product designs are still on the CAD drawing, and directly exposes excessive reaches and bends and regress. What is the disadvantage? Obviously, you're not on the floor. You still have to analyze the process, so it still is analyst intensive, measures human body physical motion, and does not calculate machine processing or chemical curing or anything non-related to the operator. Requires certified practitioners, and for the most part is not cost effective for custom low volume jobs. So this is good for repetitive high high volume, but for low volume this route is not recommended. In a nutshell, this is what we're looking at, the work measurement techniques. The site provides high-level roadmaps for the entire work measurement landscape when designing an engineering strategy for your plant. All work measurement techniques fall into these three categories, ranging from informal estimates to highly scientific, objective motion methods at the bottom. So that gives you some idea if you were looking to implement something like that in your plant or in plant, or this application actually is beyond plant. We've done it for customer service. We've done it for insurance companies, call centers. We also were asked, it didn't materialize for construction, because in construction, there is no real labor standards. We started with, we were pulled back to manufacturing. Um, so how do I choose the right measurement technique? It comes down to two variables. Number one, production volume. As you see on the first column, what is my volume? Is it in tens, hundreds, or thousands? Number two, cycle time. Is it short, medium, or long? So this is on the third column, you see the recommended approach. So that would be a good guideline for you guys if you were to develop any kind of work measurement in your environment. So what happens if I don't have lack of correct standard times? So when an organization operates with a lack of correct standard times, it isn't just a minor administrative issue. It creates a ripple effect across the entire business. As you recalled in the earlier slide, we said 40% loss in labor utilization. 40% is huge. Almost half of my operation could be waste. Walk through the consequent inaccurate quoting and margins without precise labor time. Product costing is just guesswork. Your risk of underquoting and destroying your profitability, or overcoding and losing your competition, losing to your competition becomes more, active. Unbalanced workloads, that's a huge one as well. As I said, unbalanced workloads is not only it's unfair, it creates bottleneck, it creates operational chaos. Some stations get overwhelmed while others are just sitting there. And I've seen it again and again, where we go to plants, especially for sequential operations, where one machine was down and everybody else was backed up, bottlenecks, which causes also employee burnout. Also, unpredictable lead times and damaged trust to the customers. So delivery schedules become completely unreliable, missed deadlines, directly erode customer trust and harm the brand. So it's good to know how long it takes to do the job so you can commit based on correct data and correct, as you know, garbage in, garbage out. So you want to have good data. So what is the cost of all this? Is it worth it for me? This gives you a snapshot of what it costs versus decreasing accuracy. As you can guess, the very first one, which was guessing and historical data, cost of measurement is low and the accuracy is low as well. And as you go more and more to stopwatch time study, the cost is higher, but the accuracy is higher as well. So that's something you want to consider when you want to evaluate what type of time study and what type of assessment I want to have in my plant. So I did talk a little bit about Timer Pro. So when I first came to NC State, as Cami mentioned earlier, in 2008, I was given video cameras, and the management at the time told me there's a lot of requests for time study. After research, I found a software called Timer Pro. and we started utilizing it. What it does, you take the video, and the software helps you quantify the times, provide work instructions, analyze the processes, so frame by frame assessment. So the speed of the process improved exponentially. Um, so it has work measurement has evolved far beyond physical stopwatches by incorporating digital video and analytics like Timer Pro. Engineers can record the video at the Gemba, and that's what we do. So we go to the operations, we video record the process, perform analysis, being time study. We can create instant Yamazumi charts, line balancing charts, and automatically, as I mentioned, export standardized work instructions, which delivered 70% faster study documentation. Also multifaceted. So with one video, not only we can do time study, we can do work instructions, ergonomic assessments, safety issues, and update your standards in your cost tables in your ERP system. So again, as far as the strategy, we do recommend this approach. For the most part, this is what we use, students and video software and videos. So again, to summarize our strategic framework into three key takeaways. Number one, methods first. Always standardize and optimize the process before measuring the time. Quality inputs prevent garbage in, garbage out, as I mentioned. Match strategy. Choose the proper tool, whether if you're PMTS or observation or sampling, based on the plant volume and cycle time. Again, I mentioned video AI, which is Timer Pro. This is what we use. It's a leverage video AI. It's a modern video analytics software, which bridges the engineering measurements with daily shop floor execution. And we do teach Timer Pro to individual companies if needed. Also, one of the most unique and valuable resources we provide is through our organization, Industry Extension Services, is our engineering student projects. As I mentioned, and Cami mentioned as well, oops, sorry. We do use students. We are not limited to industrial engineering students. In fact, I have 7 students on my team right now. All 7 of them are from different curriculums in engineering. We have construction, we have chemical, electrical, biomedical, of course, industrial. We're not limited to undergrad or grad. We bring PhDs if needed for more advanced analytics. That's mainly for simulation. We do supervise our students. So IES, one of my colleagues, such as Cami or myself, provides supervision while on your site, and we provide services for you. So it's a zero low-cost solution as compared to your hiring, somebody off the street and other options. So, and you always have a pipeline of talent. So you have a pipeline of talent. I had a lot of students being hired after we completed a project. And again, we hire from all academic levels, all engineering levels. And we do not only this kind of studies, which is work measurement. We have done layout improvements with of course, not necessarily using work measurement, but we have done simulation, where simulation helped us identify bottlenecks and improve the area layout. So it can be a combination of project types, and it's a multidisciplinary approach. Um, on that note, thank you for your time and attention. If you're interested in having a work measurement or any kind of project assessment that may be needed at your facility, please reach out to Cami or myself. Or was it the fourth page with regional managers in your area? Um, on that note, thank you for your time. Now we will open the floor for any questions, please.
Thank you, Holly. I'm going to go ahead and
You're
stop our
welcome.
recording.